Okay, this is to show a simple circuit. We're gonna dissect essentially a control circuit, a power circuit, and also I'm really making this video because I bought some heated seats off of eBay. Came out with its own harness. Extremely dangerous the way it's wired, mainly around the gauge wires, but we're gonna go in detail when I get there. So simple circuit. This is just a simulator that's gonna show also flow of current and etc. So if we pass it and we close our loop, lights up our light, etc. It's very simple. Think about it of water. If you're closing the loop system, then the water will flow. Obviously, we're just having one source here. When it comes to power and control circuit is a little bit what I'm going to be doing for the heated seats. So what we're looking at here is just the system. Down here we have our two heated seats. We have a relay and we have two switches here. This one is technically automatically handled by the vehicle. It's accessories. And this one will be your actual heated seat switch that's gonna turn them on. This allows us to try to turn it on when we have the vehicle off and it's not going to do anything. There is 12 volt all the time at the relay, and these relays are rated for 30, 40 amp depending. Those are the black ice block or ice cube or black cube relay, rated pretty high. And they're going to allow you to control through the coil of the relay without having the amp draw through your switch, which is what we're trying to avoid here. So your control loop is going to be this one on the tighter circle, and then your power loop is going to be the outer one going to the relay and going through the heated seat themselves. The main reason you want to do that is to not draw a whole lot of amperage through your heated seat switch, or your pre-existing wiring of your vehicle that would go through accessories. Now, obviously, some people will wire it directly from the battery with a switch, and it's going to cause similar issues with the switch itself. Those switches are rated maybe for an amp or two on the long run. This is also applicable for lighting, auxiliary lighting. If you're looking to replacing these heated seats down here for a lighting system, it's going to work the exact same way. What we want to try to avoid is running all the power through this switch. Again, these are not rated for that. You'll see a lot of melted relays or melted switch because of that reason. We're running very low power in these heated seats. They're 7.5 ohms, so we'll see the math and how much amp they're drawing, but it's around 4 amp if I'm remembering correctly. Nothing major, but where we're talking about a light bar or something like that, you're going to be drawing a couple amps, maybe 5 or 10 amps, and then that switch will melt, or you'll burn yourself trying to turn it off because it'll have so much heat sitting into it. So for example, if we again click the button, we don't have the vehicle on, nothing will happen. However, once we turn on the vehicle, the accessory will click. We'll have 12 volt waiting at the accessory bus, and then after that, if we turn on the heated switch, this is going very fast, but you get the idea. So we're activating our coil for a relay. Our control loop is closed, therefore we're clicking the relay, switching the state on the inside, and now our power loop can be activated. Now we're sending 12 volt through both of the heated seat, and obviously this is for one seat only. One is for the bottom part of the seat, the other one is for the back part of the seat. And actually this one is not functioning because I did not do this drawing schematic properly, so we're going to fix that real quick. So if I do this, it's not liking that. Let's see. Okay. There you go. Now it likes it. Let's try this again. And then if I just show, there you go, 3.2 amp. So again, we turn the car off, we leave our switch on, don't matter. System shuts off. We don't have any amp draw. Nothing's moving. If we turn it off at the switch, same concept, right? So as we turn this on, both are heating up and we have 3.2 amp draw. Now this amperage, I'll put a chart up of wire gauge per amp draw, etc., of normal rating that we're comfortable dealing with. Now, a peak rating is completely different from, um, what we would call like a constant draw, essentially. Uh, what the switch is comfortable handling, like on a peak, 3.2 amp is completely fine. We could have a momentary switch to turn on something, for example, then let go of the switch and it closes, but the loop is staying closed and staying powered. 3.2 amp, this will handle it. However, I'm expecting a heated seat to be, at least, I don't know, on for a couple hours, whatever drive you're wanting to do during winter or stuff like that. This is where it becomes a problem. The longer this stays on, the more harmful it is for the switch and the wiring, etc. One thing I did not add in line here, obviously we'll be adding a fuse in case there's any kind of short within the seats themselves, or if there's any shorts towards the wiring. But again, we're drawing a constant 3.2 amp, so we could go 5 amp to feel very safe. Again, if it's going to be a short, it's going to be grounded pretty hard, so therefore we can climb up a little bit higher. But more likely, I'll be putting a 10 amp fuse in line with the system. Now, to go with the pre-wiring of this EDC that I got, what we're looking at is something like this. Now, maybe it's a little bit more mazy, like the way it's all set up. The one thing I want to take attention to is that we only have one wire that goes through our 3-position switch. This one we had essentially 2 if we're looking at it this way. We have one wire that goes to accessories, that this could be a smaller gauge, and then a thicker wire that will go directly from the battery, and this we can up it up from, there is a joint here, but however I could wire this, and which I will, from a 2-gauge wire directly to the battery, completely not bounding myself to the accessory wiring. This, however, it's not like that. It gives you one positive and one negative wire, which is very intuitive because that's all you have to plug in, and the system works. It's not going to not work. It will work. But we're going to be passing all of that power through the switch and through 18-gauge wire, which is what came with it originally. That's where I don't feel comfortable. But anyway, let's get to what it looks like. 3-position switch, middle is off, down is, let's see, high, and top is low power. So here's what's happening. As we put it on high, the positive runs through both heated seat, same concept as what I had on mine. And this is running a little fast. There you go. Didn't realize I had this on. So we're running through, and the relay is pretty much only being used with a normally close contact for one half of the seats. And both are joined again together and running through the negative, going back and finishing our loop. Doing it like this, and we're pulling 3.2 amps, and we're pushing, obviously the resistors or the heated seats are in parallel, so therefore we're going to be running more amp, and it's going to be on high temperature or high setting. If we switch it the other way, and we're seeing the relay click the other way, what ends up happening is it's smart. It's not like it doesn't work. It does work. What is going to happen is actually going to click the relay on, utilize the contact now that used to be a negative. Now when we're running it into positive, running it through the first heated seats, this contact will have 6 volt because we already cut it in half with our resistance. They're now in series. And now we're going back all the way, looping back around to the negative. It's very smart. It's not much different in the sense that we're using the same, the same stuff as here. It's very similar. However, we are using the relay as a insulation from control circuit to power circuit, right? We don't want to have a lot of amperage to enter their switch, etc. They're using the relay from, again, whoever bought that from eBay, to do an inversion. We're inverting the power draw the positive and negative, and then we're putting from parallel to series. Pretty smart, pretty clever. With like again with just the same amount of component, a switch and a relay, couple wires, whatever whatnot. So the way they have it wired, it functions. Now here's the problem again. On low setting, the switch can it handle 1.4 amp? Yeah, absolutely. It's not gonna have any issue. It's even clicking the relay in place, and it's still running that low. So there's no issue there. The problem is whenever we're gonna put it, um, this is when it's gonna deplete its capacitor coil, and eventually it's trying to reverse backward. The resistance is holding the power long enough. I'm actually accelerated just a little bit. There you go. Now we unclicked. The issue is going to be on the high. So once we're on the high, we're running this at 3.2 amp. That's almost 4 amps, constant in an 18 gauge wire. This wire right here is the 18 gauge one I'm talking about. That comes with the kit. The switch itself is going to have a lot of amperage going through, and even our negative wire is also 18 gauge. Now the funny thing about all this is that they did include an inline fuse here, and they provided like a 30 amp fuse, which is way overkill. It'll never blow up. Surely if we ground it, it'll probably give up, but we might burn something else before that. And the relay is a 40 amp rated relay. So again, it's this relay being rated for 2 amps, obviously too low, but we could have like a regular contact relay of 5 amp and it'll be completely fine because we're not really running that much power through it. 3.2 is our total circuit, but one of them is not even going through it. The other one is, so give or take half of this. And if we switch it, what we're looking at is 1 amp. 1 amp going through the contact. And that's actually not even true because we're powering up per coil, which will take maybe, a couple milliamp to activate. So we're looking maybe at an amp or 1.2 amp or something like that. Actually, I can maybe, let's see. There you go. 800 milliamp going through the, not even an amp. So the relay's overkill for their setup. It's not necessary. It's completely unnecessary. You want to go with a big block, 40 amp or whatever you want to do, relay. If this is your setup, if the power is going through all of it, and if you're replacing this with lights that are going to consume a lot of energy, a lot of power, this is what you want to use it. If you guys are interested to do circuitry like this and do simulation for your test, and if you're going to be missing any parts, or if you're measuring, your amp draw and realizing, okay, and that's something that I did in my garage, right? I measured the resistance of the heated pad itself, and they are 7.5 ohm each. But you'll see, oh shit, like 3.2 amp, so that's way too high. It's going to melt my wires, so I need to bump it up. The website is falstad.com/circuits. Or singular circuit. You'll enter the website like this, and then there's a full screen edition right here that you can they'll give you an example that you can go ahead and delete, and you can search for all the parts that you want to add, etc. And it's a bit clunky at first. You might not be used to what it looks like or what it's supposed to look like. This is an AC circuit, that's why it's looking like this, but that's just the example they're giving us. However, this is all I have. Again, simple circuit, power and control circuit delivery, and this is just the example that I ended up with my hands on. That it was interesting to see how it was functioning. However, I will be changing this a couple of reasons. My switch don't have a high and low. The one switch that I want to go with is just an on-off, so this will be perfectly fine. And I just didn't like the wire gauge and the way it was passing through the switch, so that will be it.